Welcome back to the GCSE Maths Pro YouTube channel. In today's video, we'll be looking at the most repeated Edexcel calculator questions. This obviously covers paper 2 and paper 3 because the topics aren't really very clearly divided between the two. It's just a general mix. Just one disclaimer, I want to say that obviously don't solely rely on just this video or even just predicted papers for the topics that you are going to revise. While these are the most repeated, it doesn't necessarily mean that these are obviously the only topics and questions that will come up. So do make sure that you're doing full revision of as much of the syllabus as you can. Go through whole past papers so that you can at least be presented with questions on a variety of different topics as well. And don't limit yourself to just a few different things, because if you do, you are putting yourself at a really big risk. So we'll start off with easier questions and then we'll work through to the harder ones towards the end. And as you can see, if you want to look at the individual questions on the papers or the mark schemes, they will be listed in the top right corner of each page. So question 4, Karina has 4 tanks on her tractor. Each tank is a cylinder with diameter 80 centimeters and height 160 centimeters. The 4 tanks are to be filled completely with a mixture of fertilizer and water. The fertilizer has to be mixed with water in the ratio 1:100 by volume. Karina has 32 litres of fertilizer. They've then given you the conversion that 1 litre is 1,000 centimetres cubed. I don't know if they always give you this, so I would try and be aware of that fact, just generally anyway. Has Karina enough fertilizer for the 4 tanks? Obviously you must show how you get to your answer, it's not just a yes or no question. So, this one being a common repeated question, obviously not the literal context, but just something to do with maybe volume, possibly surface area of obviously prisms, 3D shapes, but with an actual real world context. That's what I see quite commonly in paper 2 and or paper 3. So the first thing would be to find out the volume of the cylinder. Now just be aware that they have given you the diameter, so obviously don't use the 80. Do make sure you make that the radius first. So the volume of a cylinder is, because it's a prism, obviously pi r squared to get the circle and then multiply it by the height. So as I said, we're going to be using the radius, which would be 40, not 80. So 40 squared and then times by the height, which is 160. I'm leaving it in centimeters because they have given us the conversion from centimeters cubed. So that gives us 256,000 pi. I'm going to leave it in terms of pi just for now because it's not the final answer and I don't want to round these decimals too soon. Now that is obviously the volume for just 1 tank. We want to have 4 tanks, so I am obviously going to then take my answer, 256,000 pi, and multiply it by 4. So that would give me 1,024,000 still with the pi. So we've done the volume, now I'm just working through it. I'm basically just working through it in the order of the sentences. We've dealt with this, we've dealt with the number of tanks. Now we've got the fertilizer has to be mixed with water in the ratio 1:100. So obviously this is the fertilizer, the 1 part. To 100 parts water. So I now need to share out that ratio. When we share out a ratio, we actually add the parts together. So we have 101 parts. So for the fertilizer, I'm going to divide my 1,024,000 pi by the 101. So now I've obviously got a decimal. So we've got 31,851 point, let's say 39. We'll write down a couple of the decimals. ... And that's obviously still centimeters cubed. Okay, so that's how much fertilizer I need. Tick that off. Now it's saying that Karina has 32 litres of fertilizer. So hers is in litres, mine is in centimetres cubed. You can convert it either way. I'm going to convert this into litres. That's just my choice. So litres, we're obviously going to have to divide the 31,000 by this conversion, the 1,000 centimetres cubed. So I'm just going to copy my answer so that I don't just cut off the decimals as I've written down. Now, technically you don't really need to use, obviously, the calculator for this, but you can if you want. Either way, we then get 31 point, let's say 85. That's in litres. So, has Karina enough fertilizer for 4 tanks? Well, yeah, she has 32 litres. She needs about 31.85 litres. So therefore, at the end, you do have to write yes or no. In this case, yes. So question 6, we now have compound interest. So Anil wants to invest £25,000 for 3 years in a bank. Which bank will give Anil the most interest at the end of 3 years? So we've got personal bank, which is compound interest, just 2% every year, and we've got secure bank, which is also compound interest. However, it is 4.3% only for the first year and then 0.9% for each extra year. So it's like a split interest. So just grab the formula that's on your formula sheet if you don't already know it. We're just going to deal with them both separately. So for the first one, obviously the principal amount or the initial amount is just 25,000. Then we multiply that by 1 plus 2% over 100, or if you're happy to convert it into a decimal straight away, it's 1.02. Now that's then to the power of how many years? So that's 3 years, so cubed. Now I just need to put it into my calculator. And that gives me £26,530.20. Now for the other option, we have to do it in kind of 2 steps. So we've got obviously 25,000 again we're starting with. The first year we're going to multiply by 1.043. Technically that's the power of 1, isn't it? 'Cause it's only 1 year. I mean, that doesn't really make any difference, so you can put the 1 or just not. But effectively it's for 1 year. You can work this out in 2 steps, or you could do it all into one calculation. And then for the next few years, we've got 1.009%, because we're adding 0.9% to 100, basically, as a decimal. And then that is for the rest of the time. So we've already got 1 year, so that means there's 2 years left. So you can just type that all in into one calculation, or do it separately if you like. And for that one, we get £26,546.46. Now they've asked us to compare the interest, so you could subtract the 25,000 if you want, but given that we've started with the same amount for both options, you can basically just check, okay, well, which one ended up with more money in the end? So this one's 26,530, this is 26,546. So even though it's close, technically, Secure Bank is going to give a nil the most interest. So you have to then make a decision and go, therefore, my answer is Secure Bank. Because Personal Bank gave me £1,530 interest and Secure Bank gave me £1,546 interest. Question 6, we've got a new phone costs £679. The value of the phone decreases at a rate of 4% per year. Work out the value of the phone at the end of 3 years. So I brought this one in because this is effectively the same as compound interest, but obviously a different context. It's now decreasing and it's obviously not interest. But the compounding bit is the same, and therefore the formula is basically the same. So you can use the formula from your formula sheet. The only thing to be aware of is we're not increasing anymore, we are decreasing. So what I would do is take the initial amount, or the principal amount, whatever they've called it, 679. I'm going to multiply that by, I think on your formula sheet it says 1 plus the percentage, but obviously in this case we're decreasing. So that means we're going to subtract it because we want to get a smaller answer. So just change the formula sheet 1. So instead of plus, you put minus 4 over 100 to convert it to a decimal. And then still to the power of how many years or whatever the time period is, which is 3. And now all I need to do is type that into the calculator. So I would probably round it to 2 decimal places because it's money. I don't think they'd be that bothered because they haven't specified. But I would say £600, 74 pence. And you can see that it has decreased the value, hasn't it? We have lost value instead of increasing. We're now skipping to question 12. I've seen a lot of kind of different questions, but generally around some form of coordinate problem. So here we've got A is the point with coordinates 7, 13, B is the point with coordinates minus 3, 21, and C is the point with coordinates 15, 23. M is the midpoint of AB and N is the midpoint of BC. Work out the distance between M and N. Now if they ever say work out the distance between 2 sets of coordinates, it's normally Pythagoras. You don't have to sketch this, but you can if you want to try and visualize it. That's up to you. I'm just going to show you kind of roughly what it looks like just as a bit more explanation. Okay, so I've just done a sketch of this. You obviously don't need to do this in the exam, it's just so that you can see it and understand it in this question. So we've obviously got the line AB, we've then got the line BC, and then obviously, roughly, the midpoints of those lines, M and N, and that's the distance we want, is the solid orange line. Now, the reason why I've drawn these dashed orange lines is because obviously this is a diagonal, which is effectively a hypotenuse. So what we need to do is we need to work out the midpoint of AB and BC, which are the coordinates of M and N. So to work out the midpoint, you always just add the 2 coordinates together for x and for y and then divide them by 2. It's kind of like an average, isn't it? So for M, that's the midpoint of A to B. So for x, you've got 7 plus minus 3 over 2. And for y, you've got 13 plus 21 over 2. And then you would just work those out. You can obviously use a calculator if you want, but you can also do it without. So the first one, so x would be 2 and then y would be 17. So that's M. Do the same for N, but obviously use B to C now. So for X, we've got minus 3 plus 15 over 2. And then for Y, we've got 21 plus 23. That one you could probably figure out, to be fair, but that's fine. We'll just write it down anyway. So N would be 6. And then obviously that one you can see is going to be 22, isn't it? So we've got our coordinates for M and N. Now, I just need to work out, imagine this triangle, the lengths. So for M, we know in terms of the horizontal side, that's 2 and N is at 6. So you see how that distance there, if I do it in orange, is 4. The actual length of the triangle is 4. And then vertically for M, we have 17 And for n, we know it's exactly in the middle here, 22. That's kind of messy there, but you can see 17 and 22, so the difference there is 5. So now all I need to do is Pythagoras. So we've got 4 squared plus 5 squared, because those are the vertical and horizontal sides. Obviously, at the end, we will square root. The square root of 4 squared plus 5 squared, which gives us root 41, but it is the final answer. And they've said give it correct to 1 decimal place, so now I can obviously round it. That would be 6.4. Another topic I see come up a lot in paper 2 or paper 3 is density. And this is one that you do actually need to know the formula for. So I like to just use the formula triangle. Density is mass over volume, so just remember mass is at the top. And then you can rearrange it however suits your question. So for question 13, we have liquid A and liquid B are mixed together in a ratio of 2 to 13 by volume to make liquid C. Liquid A has a density of 1.21 grams per centimetre cubed, and liquid B has a density of 1.02 grams per centimetre cubed. A cylindrical container is filled completely with liquid C. The cylinder has a radius 3 centimetres and height 25 centimetres. So again, another cylinder. Work out the mass of the liquid in the container. Give your answer correct to 3 significant figures. So this one, we're looking for the mass, which is why I like to use my formula triangle. I can just rearrange it as I need. So here we have the densities for both, but we also need the volumes. So that's why they've given us this cylinder here. So you could always start off by just working out the volume of the whole cylinder for liquid C and then sharing it out. So we've got radius 3, height 25. We know the formula from earlier was obviously pi times the radius squared times the height, which would give us 225 pi. Again, I'm going to leave it in terms of pi just for now. Centimetres cubed, because that's what the density was in as well. Now, for liquid A and B, we can just share out the ratio, can't we? So if we add that together, we've got 15. So as you know, I don't like to round anything too soon. There's quite a few steps here. So what I might actually do is just divide 225 by 15 and leave the pi, which gives me 15. So for each part of my ratio, it's 15. So obviously for liquid A, that would be times by 2. So that's 30 and then still pi. So the volume of A is 30 pi. And then the volume of B is 15 times by the 13 side, which is 195 pi. I'm only doing this just to avoid rounding my decimals, really. That's the only reason. So I've now got the volume of each, I've got the density of each, so I could work out the mass of each of them. So for the mass of A, we know it's density times volume, so that would be 1.21 multiplied by 30 pi, which obviously now is going to give me the decimal, so that would be 114 point, let's say 04-ish, and that's in grams. And then the mass of B, we do exactly the same thing. We've got density is 1.02 multiplied by volume, 195 pi. Don't forget the pi if you've done it this way, which would give us 624 point, let's say 863 maybe, just a few decimals. So let's say 862, because I can keep that answer in my calculator anyway. Grams as well. Now the last thing we need to do is then add them together to get the total mass of liquid C. So 114.04 plus 624.86. I'm going to use my previous answer though to get all the decimals there. So just straight away plus 114.04. Now I can round it. They said the 3 significant figures, so that would actually be basically the nearest whole number. So 739. Obviously grams. The next question we've got is involving circle sectors and then obviously some kind of triangle as well. So we've got area. So OAB is a triangle, OBC is a sector of a circle centre O. Calculate the area of OBC. So that is the sector bit. So I'm going to have to use the triangle to help me with the area of the sector. We should know the formula for the area of a sector. Area of a sector is pi r squared, so the whole circle, but then multiplied by the angle over 360. Now we've got the angle. Do you see how the only thing that's missing is the radius, which also happens to be one of the sides of my triangle. So that's how I figure out what to do. Okay, I need to use the triangle to work out the side OB, which is my radius. Now, it's just a scalene triangle. It's not right angle triangle, anything like that. So I've got an angle, 2 sides, and I want the third side. That to me is screaming cosine rule. So that's obviously on your formula sheet as well. Now, if you need to rearrange the letters, you can do so to make it match the formula for either cosine rule, sine rule, any of those, that's fine. In this case, it works because cosine rule is based around the angle A, so that's fine. And then you could just call this one side B. This is technically side O, but if you want to for the formula, you can call it side C just for that, so you can substitute it in correctly. So to work out OB, we obviously need to do OB squared. That's B squared plus C squared, so 6 squared plus 9 squared, minus 2 times B times C, so 2 times 6 times 9, then obviously multiply by cos of the angle, which is 35. And then at the end, we will square root it. So while that's how I'd write it down algebraically, I feel like I'd type it in slightly differently to my calculator. So as you can see, what I've actually done in the calculator is just put a big bracket and then multiplied all of the rest of this in one bracket. Now, I've got 28, although do just think about it, it doesn't really make sense to be 28 if one of them is 6, one of them's 9. We would think it would be a bit smaller, so don't forget that you do need to then just square root your answer. Now, I would use the answer button to just copy all of those decimals. So here we've got now 5.3. That makes a bit more sense, doesn't it? Now, because this isn't the end of my question, I might write down 5.34. Obviously, try and keep that answer in your calculator. So OB, which is the same as the radius, is 5.34 ... Okay. Now all I need to do is just work out the area of the sector because I've now got everything. So that's pi times 5.34, obviously ... squared. I'm going to copy my answer from my calculator anyway. Multiplied by the angle 80 over 360. So take my answer from there. I'm going to do pi, just straight on top, kind of pi, multiplied by answer squared, because I need to square it again, don't I, if I've got the 5.3, over 360 is then this. Now this is actually my final answer. So now I can round it. They said correct to 3 significant figures. That would be 19.9. And that's literally it. It's just combining those two things together. Question 17 is all about iteration. This is the one where I'm showing you all of the different kind of part A, part B, part C combinations that they could do. So part A, show that the equation x cubed plus 2x minus 6 equals 0 has a solution between x is 1 and x is 2. All you need to know about this is just remember, substitute in both values and then see what you get. So for example, x1, so when x is 1, we've got 1 cubed, just write it down. I know it seems kind of pointless, but write it down just so you've got the working out, and then work out what that is. It's not going to be equal to 0, but just to work out. You can obviously put it in your calculator, but also you could work it out yourself. We've got basically 1 plus 2, which is 3, minus 6 is minus 3. Then do the same for x being 2. So 2 cubed is 8, plus 2 times 2, which is 4, so that's 12, minus 6 is 6. Now, because it's equal to 0, when you sub in the values, you should get one answer below that, one answer above that. Being that the answer was 0 originally, you are going to get one negative, one positive. So in this case, that's one mark you need to then mention. In this particular case, because it's above and below 0, sign change, or one's positive, one's negative, however you want to write it. Therefore, what does that mean? Just copy this bit here. Just copy the sentence, literally. Solution between x is 1 and x is 2. And that's your second mark. So just memorize that, then you just repeat it every time. Part B is then, show that the equation x cubed plus 2x minus 6 equals 0 can be rearranged to give x is equal to 6 over x squared plus 2. So just figure out how they've rearranged it. Obviously, you need to write some kind of interim working out, something in the middle of those two. How do I go from this one to this one? Or you could think of it vice versa. Try and piece it together. What I would suggest is they probably move the 6 first. So I'd probably write that. So x cubed plus 2x is still on the left, plus 6, so that's our numerator. But then you can see that they've divided by x squared plus 2. So where's that come from my left-hand side? Well, I think what they've done is they've just factorised out an x to get then x squared plus 2 in a bracket, and to then leave one x on the other side. So you can see I'm then going to just divide across by that bracket. So for this question, you just have to figure it out depending on what the equation is. Now, finally, we're on part C, which is the actual iteration formula part. So they've said starting with x, 0 being 1.45. Use the iteration formula. Obviously, now they've added in n and n plus 1. So x n plus 1, so what they mean by that is the next value of x is equal to 6 over the previous value of x squared plus 2, don't forget the squared, twice to find an estimate for the solution of the original equation x cubed plus 2x minus 6 equals 0. So this time they've said twice. I feel like normally it's 3 times, but it'll be either twice or 3 times, so just double check. Give your answer correct to 4 decimal places. So this is how we're going to type it into our calculator. Starting with x0, whatever that is, whatever the starting value is, you just type it in, press equals. As you can see, now it's in my answer. Get rid of that, it's still in my answer memory. Now I'm going to type in the formula, which in this case is 6 over, wherever you see xn, that's where you put your answer button, because that's the x value, isn't it? So answer. Now it is squared, and then there's a plus 2, isn't there? So do you see how that's now my formula? But instead of xn, I now have the answer button. So if I press equals, that's going to be my first value, as in x1. So what I'd write for my working out is x1, and then I'd probably just write down that as in 6 over, and then show them that you do know that you have to substitute in the previous number. And then my answer was 1.4625. I'd probably just write down all the values on your calculator. I know at the end we're going to round it, but sometimes they don't tell you how to round it, so I would rather just write them all down, just copy it all down. Then for x2, all I need to do, so get your calculator back, then you just press equals one more time. Now it doesn't look like it's changed, but if you actually compare it, it has. It's obviously going to be a similar number, but now this is x2. If you needed to do it 3 times, you'd obviously press the equals button 3 times. So for x2, I've got 1.44963497. Again, I've just written all of them. Now this time it's only twice, so this is my final answer, but I am going to now round it to 4 decimal places. So 1, 2, 3, 4, and I don't need to round anything up. So that's 1.4496 in this case. If they don't tell you how to round it, I'd probably just copy the whole answer and put that on the answer line. Question 17, we've now got some histograms. If this already came up in paper 1, it's unlikely to come up in paper 2 and paper 3, but obviously that does change every year. So feel free if you want to skip ahead if this doesn't apply for your particular year, but it might do then for the years going forward. So question 17, some people took part in the first round of a competition. The histogram gives information about the scores of these people in the first round. 20% of the people got a score high enough for them to qualify for the second round. Work out an estimate for the score needed to qualify for the second round. So 20% of the people is the frequency, isn't it? For histograms, I like to use this formula: triangle, frequency at the top, frequency density class width at the bottom. I just remember it because frequency is the only single letter, isn't it? And that goes at the top. The other two have both got 2 letters. So I'm going to be looking to find the total frequency from my histogram, and then I'll work out 20% of it. So to work out the frequency, I obviously need to multiply the 2 axes together, frequency density and class width. So I do have to go through and do that for all 4 bars. So the first one, just be careful of the scale, make sure you're reading that correctly, is obviously 0.8 times 5, which is just 4. Then we've got 1.6 times 10, obviously 16. Then we've got 2.2 times another 10, so 22. And the last one is 1.2, but be careful, it is actually now by 15. So that's 18. And then obviously I'll add them up to find my total frequency, and you should get 60. So there's 60 people in this histogram. I now want to know 20% of that. So the way that I would normally work out 20% if I had a calculator was just times it by the decimal version, which you can see is 0.2. You could also, if you wanted to use the percentage button on your calculator, mine is here, you can see I'd have to press shift. You could just put 20, press shift, and then the percentage button if you wanted. Or if you're happy to convert it into a decimal yourself, that's fine. Either way, you should get 12. So what we're saying is 12 people scored a high enough mark to get them to qualify for the second round. Now obviously it's a high enough mark, so we're looking from the 40 backwards, aren't we? We're not looking at the left hand side, we're looking from the highest mark backwards. So this is now a frequency, isn't it? This is a frequency as well. I now need to then convert that kind of back into a class width, because I want to know one of these numbers, don't I? Something slightly less than 40, isn't it? But what is it? So back to my formula triangle, I now have the frequency. Because it's going to be from 40 down, I know that it's going to be this top box because we worked out that in this top box there were 18 people. So it is going to fall somewhere in this box, isn't it? So I do know the frequency density is obviously the 1.2. I want to find the class width. So frequency is 12 divided by the frequency density for that box is 1.2. Do you see how that would give me 10? So this is now in terms of a score. However, as we said, we are going from 40 backwards. So you would have to go, okay, well 40 is the top score. We've then said 10 marks or 10, like the score of 10 points less than 40. So that's 30, isn't it? 30 out of 40. If you got above that, you would then qualify for the second round. So 30. Okay, this is obviously a really common question. As you can see, again, all the layouts are different, but you can kind of see what this is going to be. We've got 2 triangles here, again, 2 scalene triangles. So I'm thinking probably something to do with sine or cosine rule, things like that. So we've got here to just straight away work out the length of AD. So this is the side over here. Give your answer obviously correct to 3 significant figures. So I obviously can't start with the main triangle because otherwise why would they give me triangle BCD? So I'm going to start over here. What could I work out about triangle BCD that would then help me give me more information about triangle ABD? Well, normally it's the line between them, isn't it? Normally the line that they share. So I could work out side BC. So how do I do that? Either sine or cosine rule. Let's see what we've got. In this case, we've got 2 angles and then technically 2 sides because I want to calculate one of them. That's normally sine rule, isn't it? Now just make sure that the actual opposite pairs do match up. So luckily, 109 does match up with the 12.5 side. And also luckily, my angle C, 34, does match up with the side that I want to find. So it's just straight away sine rule. So again, that's on your formula sheet. When you're looking for a side, you put the sides at the top of the formula of the fraction. So in this case, I'm looking for BD. That goes over, obviously, sine of the opposite angle, so that's the 34, equals, and then the 12.5 is the other side, over that opposite angle, sine 109. Now, with sine rule, you always have to rearrange it, and if you lay it out like this, then obviously you just have to multiply by the sine 34. So BD, to get it on its own, is obviously equal to the 12.5 over sine 109, but then multiplied by sine 34. So that's what I'm going to put into my calculator. And as you can see, I do get loads of decimals, so I'm going to keep my answer in the calculator because it's not the final answer yet. But I'll write down maybe 7.39. So BD is about 7.39, obviously technically ... So now I know this one is about 7.39. I can now look at the second triangle. I want to work out side AD. What have I now got? I've then got 3 sides, including the one I want to find out, plus an angle. So that's now cosine rule. And again, it does match up because the angle I've got is opposite the side that I want, so it does work. So what you can do for cosine rule is obviously, as I said before, if you want to change the labels to make it match cosine rule, that's fine. So for example, cosine rule is always based in angle A. So if you want to change this one to A, that would obviously then make that one side A. You could change this one to C if you wanted, which makes it still side C. And then you could change this one to B if you wanted. It just depends how confident you are with subbing into the formula. So for cosine rule, again, we're looking for a side, so leave it as, I'm going to put AD just because they've said AD. But this side here, isn't it? Leave it as the side, as the subject. So we're looking for B squared, which is 11.4, so squared, plus C squared. Now that's obviously our previous answer. So I'm going to write down 7.39 squared, but I will copy the answer in my calculator so I don't lose any of the decimals. Obviously 2 times 11.4, again, use my answer button in the actual calculator. And then cos of the angle 86. So I've still got my previous answer, so I'm going to use that. So we've got 11.4 squared plus, and then this is where I'm going to put answer squared so that I don't lose any decimals, minus, and as I said before, I'm going to open just one big bracket, 2 times 11.4 times, and then again answer, times obviously then cos of this time 86, and then I will close both brackets. Now, as we said, that is the squared version, so you want to just straight away square root your answer again. 13.14 ... Now they've said 3 significant figures. I'm going to round it because it is the final answer, so that would be 13.1. So AD is 13.1 to 3 significant figures. Something similar is then question 18 here. We've obviously got a cuboid, and we've been given some sides and some angles. This is screaming 3D trigonometry at me. So find the size of the angle between AH and the plane ABCD. This one's also very important, this exact question. Between AH, which you can see as a line that we're going to draw, and then a plane. I just want to show you how to set that up. So obviously A to H I'm going to draw. That's obviously a line that's going kind of straight through the whole cuboid, isn't it? From the bottom back corner to the top front corner. Then how do I work out what the angle is? Because it's with the plane, isn't it? Which is just the base. So for 3D trig, we are still looking for 2-dimensional triangles, just like normal flat right-angled triangles, but they're just somewhere within a 3D shape. So they could be kind of flat, as in horizontal on the base or on the top. They could be vertical, like as in they're stood upright. However, they are unlikely to be diagonal triangles, like slanted kind of through. So some people might think that this is the angle here, but it's not. Do you see how that would create like a really, I don't know, like if you were to draw a line here, it'd be like a diagonal triangle. It's not going to be that. So what you're going to then have to figure out, depending on the question, is I'm going to have to draw a line through the plane, but I'm going to draw it so that it creates just a stood up right angle triangle. So in this case, what I mean by that is I'm going to draw from A to C. A to C is a line on the base, on the plane, isn't it? It is a line on the plane, but it obviously relates to my line AH as well. And then that creates a nice angle. Do you see that? That's now the angle. I just finished the triangle. This is obviously a right angle triangle, isn't it? So that's what I would do. Just try and figure out where do I need to draw lines. Now I'm obviously going to, let's label the sides they've given us. They said A to B is 7.3, so I'll just label that there at the back. We've got CH, which is actually quite relevant to us with the orange triangle, is 8.1. And then finally angle BCA here is 48. I'll try and draw that. Okay. So we're trying to find this orange angle. Obviously, I've only got one piece of information about the orange triangle, and I will be using just normal SOHCAHTOA, normal trig. So I do need to know two sides. So that's what's I'm backtracking in my head. If I need to know two sides of the triangle ACH, I could either work out AH or AC. In this context, which is easier? Well, I have a lot of information down here on the base of my cuboid. So I probably will work out AC, because let's draw a second triangle. Don't know if you can see that, but that's the triangle ABC, isn't it? Just on the base of my cuboid. I have an angle, I have a side. I want to find out a second side. So that's also just normal trig. Sometimes 3D trig can be Pythagoras as well, so just be aware of what information they've given you. So I want to work out the side AC. If I label that, we've got the opposite, haven't we? The 7.3 is opposite the angle, and I want to know the hypotenuse. So that's obviously sin. I'm looking for the hypotenuse to cross that out. I've got the opposite, which is, so AC is the same as the opposite, which is 7.3, over sine, obviously, of the angle, 48. So again, that gives me loads of decimals, and this is not the final answer. So I might write down 9.82, but I'm going to keep this if I can in my answer. So now I know AC, we can now focus on the orange triangle. So for the orange one, I've got the opposite again, but now I've got the adjacent. So this one's now going to be tan. I'm looking for just the angle, isn't it? So that would obviously be tan of the angle, which if you want to call it x, you can call it whatever you want. X is the opposite, so the 8.1 over, now obviously I'm going to write down 9.82, but in my calculator I'm going to copy my answer. The other thing to note is because we're looking for an angle, we always do the inverse, so that would be tan inverse of the opposite, which is 8.1, over the answer, which was obviously the 9.82, but with all the decimals. So x itself, so the angle is actually 39.5 ... They have said to one decimal place, so 39.5 degrees. So there we have 39.5 degrees. Our final question is then on upper and lower bounds. So we've been given a formula here with D as the subject. We've been told that U is 26.2, correct to 3 significant figures, and A is 4.3, correct to 2 significant figures. Calculate the upper bound for the value of D, so just one of them. And we've been told to give our answer to 3 significant figures. So for the upper bound of D, we've got a divide scenario here. That's always where you need a mixture of upper and lower bounds of, in this case, U and A. So we want the biggest possible answer. We would therefore need the biggest possible numerator, so the upper bound of U, obviously don't forget that you need to square it, and then we'd need to divide that by the smallest possible number. So 2, obviously then multiplied by the lower bound of A. So that's what I need. Upper bound of U, lower bound of A. So let's work those out. The upper bound of U, it's to 3 significant figures, so we want 0.05 more. So the upper bound of U would be 26.2 and then add another 5. Anything slightly less than that would round down still to 26.2. And then the lower bound of A would be 0.5 less, so that would be 4.25. Now all I need to do is just set up my equation. So the upper bound of D would be 26.25, but again, don't forget to square it over, and then also don't forget to multiply the denominator by 2 times 4.25. Obviously we get loads of decimals. They have said to round it to 6 significant figures, so that's 1, 2, 3, 4, 5, 6, but the next number is 7, so I would round up the 1 to a 2, so 81.0662. 662, that is 6 significant figures. They then said the lower bound of the value of D is 78.6003, again, correct to 6 significant figures. Part B, by considering bounds, write down the value of D to a suitable degree of accuracy. You must also give a reason for your answer. So we're just looking at both values. Normally in this case, you just try and find some kind of middle ground where they would both round to, whether that's the nearest whole number, whether that's 1 decimal place, 2 decimal places. It depends on the question. In this case, I think, because they're kind of far apart in terms of they're almost 3 apart and there's a difference of 3 almost. So I'd probably round them both to 80, I think, which is either you can say 2 significant figures or the nearest whole number, isn't it? So I would say write down the value of D. So I'd say D is 80, and then my reason, that's obviously 1 mark. My reason is because I would say something like 2 significant figures. Let's go with that because that sounds a bit kind of fancy, doesn't it? But you could say to the nearest whole number as well. That's fine, doesn't really matter in this particular case. They both round, and then you say to 80 or whatever your number is. So it's in agreement, isn't it? To 2 significant figures in this particular case, they both round to 80. That would give you the 2 marks. So those are loads of the most common Edexcel calculator questions, obviously for higher tier. This is not to say that these are the only questions or obviously the only topics that will come up. Please make sure that you are revising as much of the syllabus as you can. We just can never predict really what's actually going to come up. So don't limit yourself just to these questions. Try to do as many past papers as you can, which will then give you a view of as many topics as possible as well. So thanks for watching this video. If you found it helpful, make sure to like and subscribe and leave down below any questions or comments that you might have.